Okay, so page 62, we have some equations. Okay. How do we know they're equations? Well, the directions say. Write an equation for each description. But we also have a word showing up here. Is, or a phrase, is equal to, okay, is, okay? Is equal to means the two things are the same, okay? That's what an equation does. It says one thing is equal, exactly the same as another thing, okay? So that is right there also an equal sign. So let's look here. So number one, we're supposed to write an equation. It doesn't say to solve it, just write it, okay? The sum, all right, so right away when we hear sum means what operation? Adding or addition. Plus, so sum of 14 and a number is equal to 17. So the sum, 14, plus, and how do we represent a number in algebra? A variable. So x, y, z, m, whatever you want to use. I'm going to use x since that's kind of like the classic variable, right? Is equal to equals 17. 17. And there's the equation. Done. All right, let's try the next one. A number. A number. So, Erica, what do we use to represent a number?
Variable.
Erica. A variable. So what variable would you like to use, Erica? P. P. Increased by. What operation would that be? Add, subtract, multiply, divide. Add. Increased by 10. So P plus what? 10. Is, so what symbol should I use there? Equals 114. And there it is. You don't have to tell me that one, I guess, right? It's too easy. Perfect, Eric. Good job. All right, you guys do 3, 4, 5. Take like a minute or two and do them. Okay. 4 is going to be a little bit tricky. I'll give you a hint. 4 is going to involve parentheses with distribution. Okay? Don't actually do the distribution. But number 4 is going to involve parentheses with distribution. Okay, so a little hint there. 4 is going to have parentheses, okay, with distribution. Okay. 4 is going to involve parentheses with distribution. So give that a try here. Question? Different. Right. What do you think? So let me ask you this. In like mathematically, what's the difference between 7 oranges and 4 oranges, for example? It's not the same. All right, I see what you're saying. So, but how much different are they? If I have 7 oranges and I have 3 oranges, how much different are they?
What does it mean by half?
How do you half of something? 0.5 times x, or 1/2 x. Now, so 10 times, so it's 10 times parentheses the sum of, so it's 0.5 x and 6. So 0.5 x plus 6 is 8. That one's a little tricky. Yeah. This right here? That was good. Oh, you're talking about these two? Can we look at these? Is what you're saying? Yes, I feel like these are a little confusing with the way they're worded, but you're right. And this is right. So, the length of a rectangle is twice its width, so that's the length. And then that's the width, right? How many lengths does a rectangle have? But you're on the right track there. Okay, I see, yeah. Yes, it's close. Only thing that should be parentheses. Oh, right here, like that. Because it's 10 times the same. Good job. Good job. Well done. Yes.
The difference is what?
So He'd be like, 30 more seconds, Sam. 30 more seconds. Okay. Let's go to Alex for number 3 there, Alex. What do you say? Negative x plus 12 equals 20. Okay, I see what you're saying. I think the difference is, so it should be like x minus 12, I think. The difference, it's in the order that you want to do the subtraction. So x minus 12. It's, no, I see what you're saying. The only time that we really like flip the order from what you see in the sentence is if you see less than. So if it was like a number less than 12, it'll be 12 minus x. So, but this case, you just keep the order the same. Okay, but otherwise, great. Thank you, Alex. Okay, let's go to Danny for number 4. Were you able to get that number 4 there, Danny, with the parentheses and stuff? Okay. All right, Erica's got it. Let's go to Erica. Sorry. Oh, wait. Oh, sorry. Reagan hasn't talked yet. I'd like to get Reagan. Go ahead, Reagan. Go ahead, please, Reagan.
I got 10 parentheses, 1 half, n plus 6 parentheses equals 8.
Okay, yes. So when you're doing 10 times a sum or 10 times a difference, the difference or the sum happen inside a parenthesis, okay? Because you need to add these two things together first to get the sum. So how do we ensure that we add before we multiply? You put parentheses around it, okay? So 10 times the sum there. All right, well done. Thank you. And then Shepard, do you have number 5?
I don't.
Okay, so, well, 2/3, that's a fraction. 2/3 a number. What operation do you think that is? Add, subtract, multiply, or divide? So 2/3, it would be like if it was 2/3 plus a number, but it's just 2/3, and really there should be like an of in there or something. This is actually multiply, okay? But let's continue here. What's the plus mean? Addition, right? So plus 4, and then is 7? Yeah, there you go. Okay? But anytime you see a fraction, like 2/3 of a number, 1/4 of a number, 1/2 of a number, that's multiplication. Okay? That's multiplication. Okay, so these are some basic ones, right, where they just straight up just give you like the English and you translate it into math. But then sometimes we have context. That is like a story happening too. And that can make it a little bit trickier. So now we're going to go back to page 55. Okay, now we're going to go back to page 55 because these have stories now. Okay, and we'll start with some easier stories and then we'll get to some more hard stories, more difficult stories, okay?
What page?
Page 55. Sorry, we're jumping around, I know. Page 55. Back to page 55 where I originally had you go. Okay? Okay. So, we're going to start right here at the suppose. There's our little story right there. Okay, page 55 is what we're on. 5. Okay, we're going to start right here where it says suppose Corey. And we're not going to fill in these blanks because I just think it's too much. We're just going to go ahead and just like write the equation, maybe in the space right here. Okay, so let's read. Suppose Corey and his friend Walter go to a movie. Each of their tickets cost the same amount, and they share a frozen yogurt that costs $5.50. Okay? The total amount they spend is $19.90. When we see that word total, what operation should we be thinking? When you total something, what add, right? Addition. Okay? How can you write an equation that describes the situation? Okay? So to write an equation or writing expressions, we sometimes have unknown numbers. What thing in this story has an unknown amount? What thing in this story has an unknown amount? Hannah? How much the tickets are, right? We don't know that. We just talked about there are tickets, but they cost the same amount, but we don't know what they are. Okay, so we'll say then that T is the cost of a ticket. Okay, T represents the cost of a ticket. Now, how many tickets are there in this story? 2, one for each of them, right? So how can I represent that in an expression? 2T, 2 times T. Okay, 2T. That's right, 2D. Sky, was that the only thing that was purchased by the 2 of them? The 2 tickets? What else was purchased? How much was that? So what should we? How can we relate that with the 2T then? What should we do?
2T plus 5.5.
Okay, very good. And we need an equation. So that's got to equal. And what do we know is the total amount there? Sky, go ahead. $19.90. $19.90. And there's our equation. We've got it. Okay. Doesn't say to solve it. How can you write an equation that represents the situation? Boom. There it is. 2 tickets plus a $5.50 frozen yogurt is $19.90. Okay. Not that bad. All right. With the price of the way movie tickets are now, I feel like that would be like closer to $30 than $20 nowadays if you go to the movies. Unless you have Movie Pass. But Movie Pass isn't as good as it used to be, I guess, either. Okay. All right, let's turn the page. We're skipping all this. It's all like these fill in the blank stupid things. I don't know why they give us all that. Okay. I guess so. There's some thinking going on. I wish they would have thought before they made some of that stuff, but that's just my opinion. All right, let's try another one here. Now, the header, the description here says creating and solving equations involving the distributive property. Okay, so now we're going to incorporate some parentheses. All right, this one's already kind of worked out for us, but we'll still think it through. Aaron and Alice are bowling. Alice's score is twice the difference of Aaron's score and 5. The sum of their scores is 320. Find each student's bowling score. Okay, so that means we're going to actually solve here. Okay, so what is the unknown quantity here? What's the unknown amount from this story? What's an unknown amount from this story? So yeah, Matt in the back.
Is it Alice?
Is it Alice's score?
Yeah.
Do we know what Alice's score is? Do we? We don't, right? We know something about Alice's score, though. What do we know about Alice's score? Twice the difference of Aaron's score and 5. Do we know anything about Aaron's score? We don't know anything about Aaron's score. Okay, so wait a minute. There are like 2 unknown quantities here. We don't know Alice's and we don't know Aaron's. Now you may remember from previous classes about writing 2 equations for a single situation. We're not going to do that here. We don't need to. The reason for that is because we're going to use Aaron's score as our variable. Okay? So you can see here we're going to let A represent Aaron's score. Then 2 times A minus 5 will represent Alice's score. Why? Because Alice's score is twice the difference. So there's twice the difference of Aaron's score and 5. So you can see we can write Alice's score as kind of related to Aaron's score. And then their total, so A plus 2 times A minus 5 is equal to 320. Okay? And once you get the equation written, then it's just solving it, right? Distribute the 2 right to there, and then combine like terms, so it's 3A minus 10. Add 10 to both sides using the addition property of equality. Divide both sides by 3, and you get A is 110. So Aaron's score is 110, and to find Alice's score, 110 minus 5 times 2. So she got 210 there, you can see. So there are their 2 answers. Okay? That was a bit trickier, because you got, you had different relationships going on. All right. Let's try this letter B here. This one it's not worked out for us. Yeah, it's not worked out. Okay. Letter B. Mary, Carlos, and Amanda collect stamps. Carlos has 5 more stamps than Mary, and Amanda has 3 times as many stamps as Carlos. Altogether, they have 100 stamps. Find the number of stamps each person has. Okay? So, we have 3 people here, and they each have a different number of stamps. Whose stamps do we know nothing about? Whose number of stamps do we know absolutely nothing about? Ben? Amanda. Well, Amanda has 3 times as many as Carlos, so we know a little.
The other one, Murray.
Mary, yeah, I think Mary, right? We know nothing, or Marie or Mary. You're right. I'm not sure how to pronounce that either, but I'm going to say Mary. So Mary's, right? Carlos has 5 more. So we'll say that Mary then. So we'll say that M equals Mary's. I'm going to use the pound sign there, or the hashtag there for number. Mary's number of stamps. Okay. So if Mary has M stamps, then what will Carlos's number of stamps be? What's the expression for that? Carlos has 5 more stamps than Mary. So what do we think there? How can you show 5 more than Mary? Let's go Joshua. If Mary has M and Carlos has 5 more than Mary, how can we write that as an expression? 5 more means 5 what? Yeah, M plus 5. You got it. Or I'm going to put 5 plus M, but it's the same thing. Good job. Okay, so that's Carlos' number of stamps. Okay, and then it says Amanda has 3 times as many stamps as Carlos. So Matt T, what should we do now to represent Amanda's number of stamps? She has 3 times as many stamps as Carlos. So what should I write for Amanda?
3 times 5 plus M.
Yeah, 3 times 5 plus M. And that 5 plus M should be in parentheses here because it's the whole quantity. So that's Amanda's number of stamps. Okay, just like that. Okay. Now, did we write is this the equation? Are these the equations?
No.
These are expressions, but no, they're not the equations. What do we know about how many total stamps there are? There are 3 people, but how many total stamps are there? 100 stamps. So that means if I take Mary's number of stamps, M, and add who else? Carlos, which is 5 plus M. And who else? Amanda, 3 times 5 plus M. That's got to equal what? 100. 100 stamps. Okay, there's the equation. Right there. Okay. And again, that's half the battle right there. That's half the battle. If you can get to this point, you're doing real well. Okay, Ben, can you tell us to solve this now, to start solving, what can we do here maybe for our next step?
Multiply 3 on the parentheses.
Times 5 and times M. Good job. Whoops. Mr. Wid. M plus 5 plus M plus 15 plus 3M equals 100. Okay, keep it going there, Ben. What would be next?
Oh, okay. Add like terms.
Very good. So the M, and the 3M make 5M. And then 5 plus 15 is 20, and that's equal to 100. Okay? And then, good job, Ben. We'll go to somebody else for this. Let's go to Mark again. So Mark, how can we continue solving from here?
You were going to subtract 20 from both sides.
You got it. And I got 5M equals 80. And then?
Divide 5 by 5.
Yes, very good. Do you know what 80 divided by 5 is? Anyone got it? 16. That's right. M equals 16. All right, so who has 16 stamps? Marie does. How many does Carlos have? Add 5, so 21. And then Amanda has 3 times Carlos. So 3 times 21, 63. Okay? Wow, that was fun. All right, folks, I'm going to give you a problem here. We got 5 more minutes left. Let's not pack up just yet. I want you to try one. We got time. All right, real quick here. Actually, wait, did I have one here that I wanted us to do? Let me see. Back it up, Mr. Wade. Back it up. And yeah, on page. Man, I wish they didn't do that upstairs. That's really distracting. Okay, we'll say on page 58, number 4. Page 58, number 4 at the top there. Okay, you've got 5 minutes. Bless you. Page 58, number 4 at the top here. I want you to try. 58, number 5. 58, number 5. I don't know why I said number 4. Page 58, number 5, please. I want you to try that one. You got like 5 minutes left, or now 4. Give that one a try, please. No, just to finish up the TenMarks if you haven't already. Yeah. So we can redo it though too. So, okay, number 5, please. Number 5. Okay, this one's already kind of set up for you. Remember that the perimeter. Okay, the perimeter is the distance around the outside there. It's kind of annoying that, yeah. This one's not quite like the ones we just did. I hope so. Just. Think about how you would write this out. Okay, and you are supposed to solve it then too. So once you got it written, but maybe let's just check to make sure that we've written it out correctly first. Okay, so just write out what you think is the relationship here. A rectangular garden fenced on all sides with 256 feet of fencing. Okay. Yep. No, you have to wait for the bell. You can go between classes. Okay. If you need to, you can drop yourself off though and go to your, when you get your instructor. Interesting. Like, it's not quite right because the length and the width are supposed to be W feet, and then that should be 8 more. And here the length is not 8 more than the width. Yeah.
Wait, the length is 8 more?
The garden is 8 feet longer than it is wide. So the length needs to be 8 more than whatever the width is.
That's right.
40 and 8 aren't different by 8.
I think I got this.
So
So the width is just the regular?
the width is W. Length is W plus
The width
8.
is 32 and the length is 40.
So be careful. There's 2 lengths and 2 widths there. So divide your edges by 2, and I think you'll be okay. Well, not divide by 2, but well. All right, hang on, folks. Here is your setup. Okay, because remember, this is W plus 8, and this is W. Okay, so you add up all 4 of those, and we'll finish this up on Monday. Okay, we'll finish it up on Monday. For W, you're saying? W is 60, and then the length would be 68. When you add up the 4 W's there, you get 4W plus 16, and then you solve.
Oh, you have to add it before.
All right, folks. So have a seat, please. Butts in the chair. Butts in the chair. There is no homework for the weekend except to finish those TenMarks if you haven't finished them. So those of you that have finished, you're good to go for the weekend. But if you haven't finished your TenMarks, you need to finish them. More questions? TenMarks are due to Monday when you come back. All right. Have a good day, folks. Okay. Bye, everyone. Have a good day and a good weekend.
What is a 10 mark and do I have to do it?
Say again.
What is a 10 mark and do I have to
You
do
don't
it?
have to worry about this right now, but the future 10 marks, I will make you. I'll show you how to do it or something like that.
So should it just be on TenMarks?
You should be able to go to your 10 marks like you normally do, and then you should be able to retake it.
Okay.
Okay, everyone
Even
gets.
though he's taken it twice, I think they blocked
Did
him
he
out.
retake it? I thought
He took
you only
it
did it
twice.
once. I thought
What?
the one that you didn't do so well on, you only did it once, right?
Yeah.
So
Oh,
yeah.
you can
So
do it
there's
again.
a
I'm
you can yeah there's a
sorry.
retake
Oh.
available.
Well,
yeah, you can do a retake.
I thought I